Hi everyone, my name is Adarsh Rajesh Shanoy, and today I'm going to discuss with you my topic optimizing smart electric vehicle charging infrastructure for grid stabilization and better utilization of renewable energy. We all know that electric vehicles are growing rapidly, and we might not be aware about how this can affect the power grid. To begin with, we need to go through why we need better electric vehicle charging stations. And this is because, as I said, electric vehicles are growing rapidly, and because of some charging that happen in a particular time frame, like evening or night, this can lead to stress in the grid. So we are going to introduce a smart charging model where electric vehicle turns into flexible grid assets. There are so many researches that's happening now to find a solution for these problems. And from the previous researches, we have some findings like, as I said, uncoordinated chargings at night can stress the grid, which can lead to voltage drops, loss of energy, and big peaks. And as a solution, a simple 5-minute smart scheduling can keep voltages healthy and reduce the energy loss. To add up with this, short-term demand predictions make scheduling more accurate and stable. And that brings us to my research question, how we can optimize the planning of infrastructure and real-time operation of electric vehicle charging infrastructure so as to maximize distribution grid stability while minimizing cost under demand uncertainty constraints. And I have made a design for this experiment, and it's like planning and operations, coordinating those two factors together and developing a new model. And firstly, we are going to planning. In planning, we have 5 different steps. It's decision, constraint, objective, methods, and output. Decision is nothing but the siting and sizing of the electric vehicle charging station. Constraints are the predefined standards of voltage hardware that we can vary. So our design should stick on these standards. And the objective is nothing but the goal of our plan, that is to stabilize the grid and reduce the cost, and also to utilize the renewable energy more efficiently. And in case of methods, it's nothing but the different models that we implement in the planning, which can give us the better result of a better map and blueprint of our electric vehicle charging station, which include data of the reinforcement of the structure and all, which comes under the cost constraint. And these data is handed over to the operation, where the rest of the design and the solutions are being found. And in operations, we are talking about the real-time operation, where there are 4 different things happening. One is the demand forecasting using a forecast guided model predictive control. And the second one is priority to low impact chargers. That is, when there's a charger where there's low charging happening and the charge is distributed first to that particular charger to bring a balance and stabilize grid. And the third constraint that was there is cost and the battery health, which we are going to solve in this section. And last but not the least, the cyber physical safety, which comes under the smart grid, where our data, the data of electric vehicle charging station are being transmitted. So the safety of this data is very important, which can be misused by hacker or some other means. So this is also very important. And that brings us to the result, which is a stable grid and better energy saving. And there's a finding from this design, that is, physics informed demand forecast improves the scheduler and prevents evening bottlenecks. That was the first constraint that we discussed in the beginning. And that comes to our overall design, how it went. There are few advantages and few disadvantages. First, we'll start with some advantages. It keeps the local grid steady. It helps to save the money, better consumer experience, better driver experience, use of more green energy, protect car batteries, works with today's networks. And some disadvantages of this model is need good and accurate data, which might not be available every time. Some sites can be quite expensive, so we can't select that site. Some economic locations need to be sacrificed also. And when we implement new software, it takes time for optimizing it. And the other disadvantage is the security of data. And every consumer might not be interested in this design, because when the power is distributed back to the grid, there might be some doubts about the cost and all. And that brings us to the future of electric vehicle charging, which is a city scale rollout which meets our goal, a smart and safe control, and next generation ultra fast charging hubs. So hope these things can be met in the future. That's all for the presentation. Thank you so much.